Hi students, our study today is about trigonometry. We're going to have series of video because in this chapter we have a lot of objectives. So we're going to start by the first video. What is a trigonometric circle? A trigonometric circle is a circle whose radius is the unit of length. Unit of length, it means it can be 1 centimeter, 1 foot, 1 yard, 1 kilometer, whatever. So the radius must be 1. And in a trigonometric circle, you have a positive sense and negative sense. Positive sense moving counterclockwise. Negative sense, you're moving clockwise. We have two measures we're going to use, the radian and the degree. However, the grade is not used anymore, so only degree and the radian. What is a degree? Degree, you all know, a whole rotation is a 360 degrees. So 1 unit of the degree is 1 over 360. So that's why the total rotation is 360 degrees. And we have another measure, which is radian. What is a radian? The radian is a measure in real number. So degree is not real number, but we can convert it to real number. They found that thousands of years ago, that if you measure the circumference of the circle, which is 2 pi r, circumference, see that you know as 2 pi r. If you measure here by a ruler, for example, over the radius, you're going to get a fixed value, and this fixed number for all circle is 6.28, whatever. So it will be 2 pi. We denote it by 2 pi. So why we denote it by 2 pi? Because we found that we have the circumference over the radius here is always the same for all circles, and this is denoted by 2 pi. So from now and on, 360 degrees is nothing else than 2 pi, but 2 pi is in radian, in number. However, in degree is different than the radian, and radian different than degree. But you can convert degree to radian. How do we convert degree from radian? You can say that 360 degrees versus, as we said in radian, is 2 pi. So if you want to have x degrees, this is a ratio. You can find its y in radian. So this is the relation between degree and radian. So directly, if this is 360 degree, which is 2 pi, so pi will be 180 degree. From here till here, if you move on the circle, this is pi. Another pi will be 2 pi, 3 pi, 4 pi. The 90 degree here, which is here, for example, this is pi over 2. Pi over 2 till here, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi. Okay, so radian is nothing else than a measure related to degree, but it is in number, and every 360 degree is 2 pi. Now, suppose we have a point M on this circle. We can go directly to point M, and suppose this point M make an angle alpha with the x-axis here, as you can see. You can go directly to point M by doing from B till M, as you can see here, or you can do a 360 degree, a whole rotation, then going to point M. You can do two rotation, 360 degree plus 360 degree, 720, then going to M. All of these are the same. Or you can go minus 360 degree till here, then going to M, or minus 360, minus 360, then going to M. Or you can do it in radian. You can say I want to go directly M, as I said, alpha, or I do 2 pi, a rotation plus alpha, or 2 rotation, 2 pi plus 2 pi is 4 pi plus alpha, or minus 2 pi plus alpha, or minus 4 pi 2 rotation plus alpha. So you can do infinitely many rotation, then going to the angle alpha. All are the same. So that's why we say any angle alpha that you can see here is the same as writing it alpha plus 360k, where k is positive and negative integer. It starts from 0, plus or minus 1, plus or minus 2, etc. In other words, k is number of rotations. So if k is 0, it means you go directly to alpha. If k is 1, you do 1 rotation, then going to alpha. If k is minus 1, you do negative rotation clockwise, then plus alpha. If k is 2, you do 2 rotation, then going to alpha. If k is minus 2, two rotation but negative opposite going alpha. Or you can go by radian. This is the same. You can go, for example, if k is 0, alpha directly. If k is 1, you do 2 pi, which is 360 degree, as we said, then going alpha. If k is 2, 4 pi, you do two rotation, then going to alpha. If k is -1, you do a rotation in negative in radian, then going to alpha, etc. So how many angle equal to alpha? We have infinitely many. So now let us start by defining some values of trigonometric, some indices of trigonometric circle. Suppose M is a point on that circle. So as we said, here we have an angle alpha. And we have trigonometric circle. This is the x-axis, this is the y-axis, and radius, as we said, here is 1. So here -1, here 1, here biggest distance 1, sorry, and here -1. So trigonometric circle is a circle of radius 1. If you pick a point, any point M, anywhere you want, so I'm taking it in the first quadrant. So trigonometric circle is split into 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. 4 90s, or 4 pi over 2. Pi over 2 we said is a 90. So here, if you project point M on the x-axis, this measure of OM projected on the x-axis, it means OP that you can see, this is cosine alpha. So the abscissa of the point M is cosine alpha. If you project it on the y-axis, this measure OQ is sine alpha, denoted by sine alpha. This is Y. So any point M on a circle, anywhere you want, for example, the abscissa is cosine alpha. For example, here this is angle alpha now, because always start from the origin. This angle alpha, it has coordinate. If you project here, you're going to get this measure. This is cosine of angle alpha, this big one. And this measure here, it will be sine of alpha. So the coordinates of a point M on a circle, x is called cosine alpha, the projection on the x-axis, and y, the projection on the y-axis, is sine alpha. Now, if you do a tangent from the point A here, it will cut this point, this line OM in the T. If you take these two triangles, OPM and OAT, these two triangles are congruent. So if you put the ratio of similarity of congruence, you're going to say OP, which is cosine alpha, over OA. We know that OA, trigonometric circle, is a circle whose radius 1, equal sine alpha over this measure 80. So if you want to find 80, 80 will be sine alpha. If you do cross multiply, 80 sine alpha over cosine alpha. This sine alpha over cosine alpha, which is the measure of 80, this is called tangent. So what is tangent? Tangent is sine over cosine. So let us repeat. If you pick a point M on a circle, this trigonometric circle is a circle whose radius is 1. If you project on the x-axis, this measure here is called cosine alpha. And this measure here is called projection on the y-axis is called sine alpha. And by the line 80 here is called tangent alpha, which is sine alpha over cosine alpha. And since cosine alpha is the projection on x-axis, and the biggest distance here is 1, it varies from -1 till 1. So cosine alpha cannot exceed the boundaries of -1 and 1. It's always between -1 and 1. And similarly for the sine. Now, we have inverse of each one. The inverse of cosine, which is 1 over cosine alpha, because we're going to use it, it will help us in problems. This is called secant alpha. So secant alpha is what? 1 over cosine alpha. And cosecant alpha is 1 over sine alpha. 1 over sine alpha. So 1 over sine alpha is cosecant, and 1 over cosine alpha is secant, and 1 over tangent alpha is cotangent. So what can you deduce? We can deduce cosine alpha. If you do cross multiply, cosine alpha times secant alpha is 1, sine alpha times cosecant alpha is 1, tangent alpha times cotangent alpha is 1. And cosine alpha is always between -1 and 1, sine alpha between -1 and 1, because I want the inverse, because sine is of the form 0.1 over 0 point is always bigger or equal to 1 for secant, and cosecant is always bigger or equal to 1 in absolute value. So sine alpha, if you have any point on a circle, like here, if you projected, this measure is cosine, this measure here is sine, tangent is sine over cosine, secant alpha is 1 over cosine, cosecant alpha is 1 over sine, cotangent alpha is 1 over tangent. Because tangent is sine over cosine, cotangent will be what? Cosine over sine. So tangent is sine over cosine, and cotangent is cosine alpha over sine alpha. You need to memorize these. So we have cosine, we have its inverse secant, we have sine, its inverse cosecant, we have tangent, which is sine over cosine, we have its inverse cotangent, and cotangent, which is 1 over tangent, is cosine alpha over sine alpha. So now we're going to continue. So don't forget, tangent alpha is sine alpha over cosine alpha. Cotangent alpha is cosine alpha over sine alpha. And the projection of any point M on a circle on the x-axis, as you can see here, is cosine alpha. And the projection on the y-axis is cosine alpha. And tangent is sine over cosine. And secant, you have in the middle E, take it as, for example, here, if you take cosecant, and we said here it's sine, so this is a mistake. I corrected before. It's sine alpha. Cosecant in the middle, what do you have? You have S, so it starts with S. Secant, E, take it like C, not to forget. E like C, S in the middle like S. Cosecant is 1 over sine, secant is 1 over cosine. So let us continue. As we said before, now if you have this trigonometric circle, let me draw a circle here. So the period of cosine and sine is 2 pi. Why? Because if you go alpha or 2 pi plus alpha or 4 pi plus alpha or minus 2 pi plus alpha or whatever, all are the same. So that's why if we have cosine alpha plus 2k pi, 2k pi is like 0, is cosine alpha. Sine alpha plus 2k pi is sine alpha. Secant alpha plus 2k pi is secant alpha. Cosecant alpha plus 2k pi is cosecant alpha. Or it's in degree the same story. So if you add 360k or 2k pi, whatever, all are the same. So the period of sine, cosine, secant, cosecant is 2 pi or 360 degree. What I mean here, if you have, for example, cosine alpha plus 6 pi. 6 pi is a 3 rotation. We said 2 pi is a rotation, so I have 3 rotations, so you can cancel this 6 pi. You can write it as cosine alpha. If you have, for example, sine alpha plus 720 degree. 720 degree, it's 2 times the 360, so 2 rotations, so you can cancel it. So directly you can write it as sine alpha. So for tangent and cotangent, we're going to learn later on that period for tangent and cotangent is k pi. Why it's k pi? It's 180. For sine, cosine, secant, cosecant is a 360. For tangent, it is only 180, 180 in a point diametrically opposite. Why? Because if you take these two triangles are congruent, because they have the same angle, radius is the same here, 90, congruent. So if you do tangent, tangent is sine over cosine. Here, because this is a trigonometric circle, here positive over positive in the first quadrant. In the first quadrant here, positive, positive. Here, negative, the cosine, but equal to that one. And the sine also down, negative. So, but they have the same distances. So if you do the ratio, here, this one over that one is the same as this one over that one. So that's why we say the period for tangent and cotangent is not only 360k, but is k pi or 180k, even and odd. I mean here tangent, for example, alpha tangent alpha plus 180 degree is the same as tangent alpha, or tangent alpha plus 3 pi. I have 3 pi in it. It's the same as tangent alpha. Cotangent alpha plus 7 pi is cotangent alpha. Cotangent alpha minus 2 pi minus 3 pi minus 4 pi minus 5 pi minus 6 pi, all are the same, which is cotangent alpha. However, sine alpha plus 8 pi is sine alpha. Sine alpha plus 9 pi, you can cancel the even. I mean sine alpha plus 9 pi, you write sine alpha plus pi, because 9 pi is 8 pi plus pi. 8 pi is 4 rotation, cancel it, remains a pi. So in cosine and sine, I cannot cancel the odd number of pi. We're going to talk about it in details later on. Now in trigonometric circle, as we said, we have 4 quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4. Imagine you have the xy axis. In the xy axis here, the x is positive, the y positive. So cosine here is positive, and sine here is also what? Positive. And tangent is sine over cosine, which is plus over plus. In the first quadrant, tangent what? In the first quadrant is positive. And I didn't put here secant, cosecant, and cotangent because secant follow cosine, cosecant is 1 over sine, and cotangent is 1 over tangent. So it follows. In the second quadrant here, you know that here the x-axis is negative, and here the y-axis is positive. So that's why here the cosine is negative in the second quadrant between pi over 2 and pi. In the first quadrant between 0 and 90 degrees. 90 degree, we said it's pi over 2. Between pi over 2 and pi, this is pi, and this is 90. Between 90 and 180, which is pi over 2 till pi. Here, the cosine is negative because if you pick any point M here, if you project it, the cosine of the point M, the abscissa, it means, is negative. However, the sine is positive. So sine positive, cosine negative. Tangent is sine over cosine. So plus over minus here, the tangent is minus, similarly to the cotangent. In the third quadrant, this is pi, this is a 3 pi over 2 or 270 degree. Why it's 3 pi over 2? Because here I have 1 pi over 2, 2 pi over 2, 3 pi over 2, 190, 290, 390, 270, 1 pi over 2, 2 pi over 2, 3 pi over 2. So from pi till 3 pi over 2, you all know that sine is negative and cosine is negative here and sine is negative. So both are negative. So tangent will be minus over minus is plus. And the last quadrant from 3 pi over 2 till 2 pi, or from 270 degree to 360 degree. Here the cosine is positive and the sine is negative. However, tangent will be sine over cosine, which is minus. So imagine this trigonometric circle. In the first quadrant, x and y positive, so cosine and sine positive. In the second quadrant, x negative, cosine negative, sine is positive. In the third quadrant, both of them are negative, sine and cosine. And in the last quadrant, cosine is positive, however, sine is negative, and tangent is the ratio of sine over cosine. So now we're going to start by the remarkable angles. What is the remarkable angles? Remarkable angles are the angles that we can know its value. So first of all, what are the remarkable angles? The first remarkable angles is 180 degree, which is pi, the 90 degree, which is pi over 2, the pi over 3, pi is 180, we said, over 3 is 60 degree, pi over 4, 90 over 4 is 45, sorry, 180 over 4, 45, and pi over 6, this is radian, this is degree, pi over 6, it's 180 over 6 is, sorry, here it's 30 degree. Okay, so the remarkable angles are all angles of the form pi over 1, pi over 2, pi over 3, pi over 4, pi over 6. Pi is 180 degree, pi over 2, 90, pi over 3 is 60 degree from here till here. Pi over 4 is the middle of every quadrant, here pi over 4. And pi over 6 is 30 degree. So how many 30 degree we have in trigonometric circle? If you divide 360 by 30, you're going to get what? 12. So how many 30 degree? We have 12. So 12, and you know, every 90 you have 330. So if you start here by the origin, this is the first 30, this is the second 30, this is the third 30, 4, 5, 6, 730, 830, 930, 1030, 1130, 1230. So you can move 30 plus 30, 60 plus 30, 90 plus 30, 120 plus 30, 150, 180 plus 30, 210, 240, 270 plus 30, 300, 330, 360. You can move in radian. How do we move in radian? This is pi over 6. 2 pi over 6, 230, 2 pi over 6, pi over 3. 3 pi over 6, 330, 1, 2, 3. 30 is pi over 6 in radian. Pi over 6, 2 pi over 6, 3 pi over 6. Simplify it, pi over 2. 4 pi over 6, 4 pi over 6, 2 pi over 3, 5 pi over 6, 6 pi over 6 is pi, 7 pi over 6, 8 pi over 6, 4 pi over 3, 9 pi over 6, 3 pi over 2, 10 pi over 6, 5 pi over 3, 11 pi over 6, and 12 pi over 6, which is 2 pi. Or you can move negative, minus 11, minus pi over 6, minus 2 pi over 6, minus 3 pi over 6, minus 4 pi over 6, minus 5 pi over 6, etc. if you move. So this is the positive sense, this is the negative sense. Pi over 4 is the middle. How many pi over 4 we have in a circle? We have in each quadrant, we have 245, so we have 8. This is the middle. 45 plus 45, 90, plus 45, 135, plus 45, 180, plus 45, 225, plus 45, 270, plus 45, 315, plus 45 is a 360. Or you can move in radian. Pi over 4. This is first 45. 2 pi over 4. 2 pi over 4 is pi over 2, 90. 3 pi over 4. 3 pi over 4, it means this pi over 4 here, it means 45. I have a 345. 1, 2, 3. 4, 45. 4 pi over 4, which is pi. 1, 2, 3, 4. 5 pi over 4 here in the middle. 6 pi over 4, 3 pi over 2. 7 pi over 4, 8 pi over 4, which is 2 pi. So circle has 12, 30, and it has 845. Concerning pi, how many pi we have? We have 2 pi. 1 pi, 2 pi. How many pi over 2? 4. 1 pi over 2, 2 pi over 2, which is pi. 3 pi over 2, 4 pi over 2, which is 2 pi. Suppose I want to locate now these angles that we have here. I want 7 pi over 2. I read it as 790. Pi over 2 is 90. 790. So 190, 290. This is 90. 390, 490. A circle has 490. 590, 690. This is 7 pi over 2. So this is the first one. First. 7 pi over. So let me write because I don't have a space to put all of these. So this is the first one. First. Here the first. Minus 11 pi. Pi is 180. So here you're going to see here even number, here odd number. Negative, we go how? Backward, clockwise. Minus pi. Pi over 2, you move like this, minus pi over 2. I want minus pi, minus 180. Minus pi, minus 2 pi, minus 3 pi, minus 4 pi. So here even, here odd. So here minus 11 pi. If I want 16 pi, it will be here at the origin. 7, let me keep this for a while. I want minus 28 pi over 6. Pi over 6 is 30. How many 30 I want? I want minus 28. Negative, I move backward. I know the circle is 12, 30. This is 30, 12, 30. Another 12, 24. Minus 24 remains minus 4. The quadrant is 330. So minus 12, minus 24 remains minus 4. 1, 2, 3. This is minus 28 pi over 6. This is minus 28 pi over 6. Suppose here minus 28 pi over 6. Now I want 11 pi over 4. Pi over 4 is 45. So circle you have, in a circle you have 8 45. Pi over 4 is 45. So in the quadrant you have 2, 2, 4, 6, 8, 10. This is 11 pi over 4 in the middle. I want minus 11, minus 2, minus 4, minus 6, minus 8, minus 10, here minus 11 pi over 4. Suppose I want, before going to pi over 3, minus 7 pi over 6. Pi over 6, we said it is 30. 30. So I want minus 730. Each quadrant you have a 3. 330. 30 times 3 is 90. So minus 3, minus 4, minus 5, minus 6, minus 7. So this is minus 7 pi over 6. Now, not to do a mistake, I want pi over 3. Pi over 3, I want 17. I have here 17. Pi over 3 is 60. 60, how many 30? It's double. 60 is double of 30. So if you have 17, 60, double will be 30. So double of 17 is 34. So to circle you have 12, 24. I want 34, remains 10. 24 to 34 remains 10. 3, 6, 9, 10. So this is 17 pi over 3. I want 7 pi over 3. 7 pi over 3, 760. 760 is 1430. Circle is 1230. 13, 14. This is 7 pi over 3. I want minus 7 pi over 3. So minus 14, if minus 760, it means minus 1430. Minus 14. Circle is minus 12. Minus 13, minus 14. This is minus 7 pi over 3. So when you want to locate an angle, it's very important to know that the circle you have 2 180, 1 and 2. You have 4 90s, 4 pi over 2. You have 12 30, 12 pi over 6. You have 6 pi over 6. Pi over 6, it means 60 degree or 30 degree. Pi over 3, sorry, it's 60 degree. You convert it directly to 30 degree. And for 45, you have 8 because each quadrant here, it's in the middle. Each quadrant, you have 2 45. So 2, 4, 6, 8. Now in the second video, we're going to talk, because still we're reaching 30 minutes is enough for the first time. So in the second video, we're going to talk about values of remarkable angles. So see you in the second video. Thank you for listening.